Hey guys, welcome to day 8 of 100 Days of Code. And today we're going to be looking at functions that allow you to give them inputs. And once we've learned all of that and we've grasped it, then we're going to be building a cipher program. And the cipher program is called Caesar cipher. So Caesar cipher is a really quite ancient type of encryption. So the story goes that when Caesar wanted to send highly sensitive military messages, he would encode his message so that each letter would be shifted by a predetermined amount. So let's say that we wanted to encode the letter A and we shift it by 3. Well, then A becomes D, B becomes E, and so on and so forth. And this is what the final version will look like. Let's go ahead and encode something. So I'm going to type encode to start encrypting a message. And then I'm going to type my message with no spaces in between. And then I'm going to give it a shift number. So this is going to be a number that the recipient and I are going to agree on so that we know how to decode the message. Let's put that at 9. And then it's going to give us the encoded result, which is something like this. And this will be the message that I'm going to transmit to my friend, either through a letter or through an email. And it means that whenever somebody comes across this message, they won't really know what's going on unless they knew the shift number. So let's say that I am my friend. I've just received this message. And I'm going to go ahead and type yes to go again. And in this case, I'm going to decode instead of encoding. And then I'm going to paste the message and hit enter. And of course, the shift number is 9. And now I have the decoded result, which I can read and understand. By the end of today, you would have learned about functions with inputs. You'll know what the difference is between arguments and parameters. Once you're ready, once you're loaded up on coffee, then head over to the next lesson and let's get started. To get started, we're going to learn more about functions. And previously we learned that functions are a really handy way of taking a complex set of instructions and packaging them together inside a block of code that has a name given to it. And when we need all of the lines of code that's packaged inside this function, all we have to do at any point later on in our code is just to call the function by typing its name and then a set of parentheses. And when this line of code is run, it's going to search for where this function is defined, which is up here, and then it's going to execute all the lines of code that are contained within it. Now, it's been a little while since we've seen functions, so I want you to go ahead and find the starting replit for day 8, which is at this URL, and then fork it to create your own copy. To begin, I want you to create a new function called greet, and I want you to give it 3 lines of print statements telling it to do 3 things. And finally, once you're done, go ahead and call the function so that it gets executed in the console. So pause the video and give that a go. All right, so to create a function, we of course need the def keyword. And we know it's a keyword because as soon as we type it, it changes to the blue color. And after the keyword, we get to give our function a name. So in my case, it's called greet. Now, after the greet, we add a set of parentheses after the name of the function. Finally, we add a colon and we enter into the block of code because we're indented over. Now, the first thing I'm going to do is to create a print statement that just says hello. And then I'm going to say, well, how do you do? Now, nobody in England actually says this, but I always see it in the Learn English books, which is quite funny. I think people will give you very strange looks if you go to somebody at the bakery and say, well, how do you do? But anyways, now finally we're going to add a final print statement, keeping in line with the Britishness of my function. I'm going to ask about the weather. Now this line, on the other hand, is something that you will often hear British people say. They're obsessed about the weather, mostly because it's terrible all the time. So now that we've created our function, it's time to actually trigger the function, or what we say in programming lingo, call the function. And we do that by calling the name of the function and then adding a set of parentheses. And now, once the code reaches line 6, it's going to search for this greet function, which you'll find over here, and then it's going to carry out each of the lines of code one by one. So let's run the code, and you should see each of the 3 print statements being called. So that's pretty simple. Notice that every single time I call the greet function, it's going to do the same thing, right? It's just going to print out those 3 lines of code. Now, in reality, it's very rare that you'll want to repeat the same instructions every single time when you call a function. It would be nice, wouldn't it, if we could modify some of the parts of the code inside the function and allow for a little bit of variation. For example, it would be nice if we could greet somebody by their name. So they could say, "Hello, Angela," instead of just "Hello, how do you do, Angela," so that it could change each time I call this function. Maybe next time it'll be, "How do you do, Jack Bauer," etc. So how can we achieve this kind of functionality? Well, we need to look more closely at these parentheses. Now, what we can do is we can actually add the name of a variable inside those parentheses to start giving our functions some inputs. So let's say that there's a variable called something that's going to be passed to my function. And this something can then be used inside this block of code, this function, and I could do something with it. Now, in order to actually pass this value when I call my function, I have to add the data inside the parentheses. So let's say I decide to pass 1, 2, 3 over. Well, in this case, when this line of code gets triggered, the computer is going to search for where this function is declared, which is up here, and then it's going to pass over this piece of data, 1, 2, 3, over to this variable called something. So now, effectively, inside this function called my function, we now have a variable called something that's equal to 1, 2, 3. And that can then be used inside the block of code to do something with that piece of data. Now, it's a bit like plugging a USB stick into a computer. If we took a different piece of input, we would end up with a different file being shown by the computer. So this means the computer can do something different depending on the input that we give it. And if we change that input, then it will receive a different piece of data. So in addition to a simple function, we can also create a function that allows for input. And to do that, you saw earlier on, the syntax is again the same as before. We use a def to create the function, and then let's just give it a slightly different name to differentiate it with the previous function. Greet with name. And then inside the parentheses, instead of leaving it blank, we get to create the name of the variable that's going to be passed over. So let's just call it name, because that describes the data that's going to be received. It's going to be the name of the person that I wish to greet. So now let's add a colon, and finally we can create our print statements. So I'm just going to copy these print statements from above. And now, instead of having these names hard-coded in here, I'm going to delete it and I'm going to replace those names with the value of this variable. So I'm going to put it in using an F string like this, and then I'm going to do the same down here. When we actually call this function, it's also going to be a little bit different from previously on line 6. So now, firstly, the name of the function has changed, but notice how it's expecting some sort of input inside the parentheses, and it tells me that it wants to receive a name. It's when we call the function that we actually pass over the piece of data that's going to be stored inside this variable. Let's give it my own name, Angela. And now when I hit run, I want you to predict what's going to happen, what's actually going to be printed. So let's go ahead and comment out the previous line of code and now run our code. And you should see that it says, hello, Angela, how do you do, Angela? So this piece of data has basically been inserted under this variable name, and then it's been put into both of these print statements. Now, if I go ahead and call this function with a different piece of data, say a different name, then it's going to use that piece of data to modify this function so it does something a little bit different. So this way we can create one function that carries out some instructions, but every time we execute it, we get to modify it a little bit by changing the inputs. When we're talking about functions with inputs, there's two things that we're working with that's really important to differentiate. So we know that when we call this function and we pass over this piece of data, effectively, we're creating a new variable called something, and we're setting it to equal this piece of data that we're passing in. Now, in programming lingo, you'll hear this being referred to as the parameter, and this piece of data being referred to as the argument. Now, the argument is the actual piece of data that's going to be passed over to this function when it's being called, whereas the parameter is the name of that data, and we use the parameter inside the function to refer to it and to do things with it. Now, very often on the internet, when you come across somebody explaining something, be it on Stack Overflow or in some piece of documentation, you'll hear them referring to these two types of things, the parameter and the argument. So if you need to, come back to this lesson and remind yourself the difference between those two things. The parameter is the name of the data that's being passed in. The argument is the actual value of the data. Now, sometimes people also get confused on the internet between these two words, but as long as you know what they mean, then you'll be in a good place. In the last lesson, we saw a very simple form of a function that allows for an input. Now, in this lesson, I want to take it even further, and I want to create a function that allows for multiple inputs. So let's comment out the previous line of code, and let's create a new comment, functions with more than one input. And I'm going to create a new function called greet_with. And in this case, it's going to take two parameters. It's going to be name and location. If you remember, this is how we added a parameter previously. Now, as a challenge, I want you to quickly think about how you might add two parameters. One's called name and one's called location into this function declaration. Pause the video, have a brief think, and then we'll go through it together. All right, so we know that if we wanted to add one parameter, name, then this is how we would do it. We would just add it inside the parentheses. Now, if we want to have more than one parameter, all we have to do is just add a comma and then add the second parameter, which we said was going to be called location. So now this particular function is going to take two inputs, the name and the location. And then inside this function, we're going to use the name to print something like hello, name, and then we're going to print and ask them what is it like in their particular location. See if you can modify this to use the actual parameters and to replace them with print statements so that we use these parameters inside our function. Pause the video now and give that a go. All right, so essentially we want to create a print statement here, and print statements print strings. So we have to add some quotation marks around that text. And then finally, I'm going to use a f string to replace this parameter name inside this string so that the data that gets passed in gets replaced here and it says hello, whatever their name is. And then I'm just going to do the same thing over here. And notice that with Replit and a lot of other text editors, you can simply highlight a word or highlight a sentence and then use the open curly brace to actually add the brace around both sides of the word. And you'll notice that I did the same thing with the quotation mark. So highlight the whole sentence and then hit the double quote key, and it will keep adding quotes around both sides of your highlight. But I only actually need one. So that is our function completed. And now it means I can call this function by calling greet with, and it's going to prompt me to add both of these inputs. And the first piece of data is going to be the name, and you can see it's giving you a hint by underlining the name of the parameter here. And let's put Jack Bauer. And then we can add the second piece of data and separate it with a comma. And now you can see this underline has moved to the location parameter. So again, a hint as to what kind of data it wants. So let's say that Jack Bauer is nowhere. Now, if we go ahead and run this code, then you'll see that it's going to print hello and replace name with Jack Bauer. And then what is it like in nowhere? So nowhere gets replaced with this location. So that means that you can now put in as many pieces of inputs as you want and modify the functionality of your function to make your function do different things each time. Now, here's a question. What happens if I call the same function greet_with, but I switch the order of the data that I give it? So let's say the first piece of data I give it is nowhere, and then the second piece of data is Jack Bauer. So we've just switched the order of these pieces of data. Now, what do you expect to happen? Pause for a moment and have a think about what you expect to be printed in here, and then continue. All right, so let's click run, and you can see that it's now complete nonsense. Hello, nowhere. What is it like in Jack Bauer? And what's actually happened here is it takes the position of the data, looks at both of these arguments, and the first argument gets assigned to the first parameter, the second argument gets assigned to the second parameter. So in this case, when it's actually gone in here, name is now equal to nowhere, which is why this line printed this, and Jack Bauer is now assigned to location, which is why it printed this second line, like so. And in Python programming, this is called a positional argument, because when we call the function, we haven't specified anywhere which particular parameter we want to associate these pieces of data with, so it's just gone and looked at the position. Now, this is the default way of calling functions, because on one hand, when you're typing out the code, you get the hints here as to which piece of data you need to enter, but also you can refer to the function and look at the order of the parameters. Even if we had more inputs, let's say in this case we had A, B, and C, and we put the arguments 1, 2, and 3, then it means that our variables that gets created will be A equals 1, B equals 2, and C equals 3. Now, if we switch around the order of the arguments in the function call, now what will happen is A is going to be equal to the first argument. So A is now equal to 3. B is equal to the second argument, and C is equal to the third argument. So it might be doing slightly unpredictable things in here. So whenever you're creating code and you're using these positional arguments, and you're just inserting the data one by one like this, and it does something completely unexpected, then be sure to check your positioning and to make sure that it matches with the position of the parameters. Now, what if you wanted to be more clear when you actually call the function so you don't ever encounter this problem? Well, you could use something called keyword arguments instead. So now, instead of just adding the arguments into the function call like this, we can actually add each of the parameter names and an equal sign to say that the first parameter A should be equal to 1, B should be equal to 2, and C equals to 3. And now, when we actually change the order around, it doesn't matter how we order it, it's still going to abide by these bindings. So C will still be 3 and A will still be 1. As a challenge, I want you to take this previous function, greet with name and location, and I want you to call this function down here. But this time, instead of using positional arguments, I want you to use keyword arguments. So pause the video and try and give that a go. All right, so when we call the function, we still use the name. So it's greet with. So everything up to the first parentheses is the name. And then we add in each of these parameter names And then we add an equal sign, and finally we give it the actual value. So let's say Angela, and then the location is going to be equal to London. Now, when I hit run, you can see it does pretty much the same as before. It puts Angela into name, London into location. But this time, if I switch the order around, it no longer matters. And when I hit run again, you can see it does exactly the same thing because it now knows which argument is associated with which parameter. So this can make your code less error prone, but it does make each line of code longer. I recommend using your judgment to figure out when you want to use which type of argument. And depending on the need, you can pick between these two. Now, in the next lesson, I've got a coding exercise for you to put into practice everything that you've learned so far. Head over there when you're ready, and let's give it a go. All right, so in today's coding challenge, we're going to do a little bit of wall painting. And the idea is we're going to create a program that helps us calculate how many cans of paint we need to buy for a given surface area of wall. The maths involved is very simple, and I'm going to talk you through it if you're not confident with maths. But essentially, we want to be able to use our inputs to modify our function so that it does something every single time we use it. Go ahead and click on day 8.1, area calculation, and we're going to complete this coding challenge. So firstly, you'll notice that down here on lines 10, 11, 12, and 13, I've got some code that's going to help us check your solution, and we're going to use your function to actually calculate the number of cans of paint we need to buy. You're basically painting a wall, and the instructions on the paint can says that 1 can cover 5 square meters of wall. Given any height and any width, your program needs to calculate how many cans of paint you need to buy. The maths, as I say, is pretty simple. All you have to do is multiply the height by the width to get the area of the wall, and then you simply divide it by the coverage per can. We said that 5 square meters per can, so it means you're always going to be dividing by 5. So let's say that we had a wall which was 2 meters high and 4 meters wide, and the coverage, as always, is going to be equal to 5. Then the calculation would be as simple as 2 times 4 divided by 5, which is 1.6. So we need 1.6 cans of paint. But because you can't buy 0.6 can of a paint, I've tried this in the store, they said no, and they told me to go away. So we actually have to round up to the nearest whole number. So in this case, we need to buy 2 cans. Now, the really important thing to draw your attention to is down here, I actually call the function. So I'm calling the function and I'm giving in some named arguments. So this is really, really important. If you review the previous lessons, then you should know what name you need to give your function and what name you need to give the parameters for the code to actually work without any errors. Remember to take a look at the example inputs down here and example output because you need to print out something along these lines. So it should say you'll need X cans of paint depending on your calculation. And finally, if you need a hint as to how to round up a number, then you can either go ahead and Google for it, use Stack Overflow, that's probably the best way, or you could give it a guess. And finally, if you really get stuck, take a look at the hint section. And once you're done, then come back over here and we'll walk through the solution together. Pause the video now and go ahead and complete this coding exercise. All right, so did you manage to get that right? If not, take a look at this video, and then once you're done, take a look at the solution code and try to compare against your code to see if there were any errors that you made. Now, this challenge is pretty doable. All we have to do is to create our function, and we create any function using def. And how do we know what name to give this function? Well, we take a look at where the function was called down here, and you can see that it's called paint_calc. So this is what we have to give our function as the name. And then we of course have our parentheses, our colon, and then inside here we're going to do all the calculations. Now the next thing we have to look at is what name we should give our parameters. And you can see I've got named arguments here. So that means each of these are going to be the names of the parameters: height, width, and cover. So the parameters are going to go inside the parentheses: height, width, and cover. And it's only if we actually spell these parameters exactly the same as what we've got down here in the argument will our code actually work. Now let's go ahead and take the height and multiply it by the width to get the area. So area equals height times width. And then with that area, we can divide it by the coverage per can. So let's call it num of cans equals area divided by cover. And now remember that this is going to be a decimal number occasionally, like here, and we have to round it up to the next whole number. If we take a look at this particular Stack Overflow, you can see that the question is exactly what we want, right? How do you round up a number in Python? And if you did some Googling, then this might have been the Stack Overflow question you would have landed on. And essentially it tells us you have to import maths, and from the math module you use a function called ceiling, and then inside the parentheses you put in the input. To do that, we first import maths. It's math without the S, and then we can call math.ceiling and wrap this result around the parentheses. So this is going to take the result here from a decimal number to a whole number by rounding it up to the ceiling. So now we're finally ready to give our output. So we're going to do that by printing it. So we're going to print, and I'm definitely going to need an F string. So I'm going to put F in there and paste this string. And instead of having the hard-coded 5 here, I'm going to put in the num of cans instead. So now when this line of code on line 17 calls paintcalc, passing in each of these arguments, then it's going to be able to run this function here and print out how many cans of paint I'll need. Now all we have to do is test our code. So let's hit run and let's put in a random height. Let's say it's 5 meters high and 3 meters wide. And it tells us that we need 3 cans of paint. So 5 by 3, the area is 15 square meters. 15 divided by 5 is 3. Now what if we had a decimal number? Let's say we had a height of 7 and a width of 13. Then in this case, it tells us we need 19 cans. So 7 times 13 is 91. 91 divided by 5 is 18.2. And 18.2 rounded up is 19. And we've now completed this challenge. Did you manage to get it right? If not, be sure to watch this video and see if you can go back and fix your code, and you can compare it against the solution code I've got here by going to this link right here. And once you're done, head over to the next lesson where I've got a slightly harder coding challenge for you. All right, so in the next coding exercise, we're going to be building a prime number checker. And a prime number, just to remind you, is a number that is only divisible by 1 and itself. So, for example, 2 is a prime number because it can only be divided by 1 and 2. 3 is also a prime number. Similarly, it can only be split into 3 equal-sized chunks. But 4, however, is not a prime number because while it can be divided by 1 and 4, it can also be divided by 2. So 2 times 2 is 4. Essentially, a prime number is a number that can't be broken to smaller parts other than 1 and itself. And it's this property of prime numbers that makes them really useful to everything from cicadas to Bitcoin and also encryption in the computer world. So if you head over to day 8.2 prime number checker, you'll see the starting code, including the number that we're going to be sending over and checking. And then, of course, the line 11, where we actually call this function and pass over the number. So this part is really important when you are creating your function. The idea is that you're going to be creating a function here that checks whether if the number that's passed in is a prime number or not. And if you take a look at this chart, then you'll see all the prime numbers up to 100 highlighted in yellow. There's a couple of things you need to remember. One is that you'll probably need to use the modulus, which we've seen before. And if you can't remember how to use that, then take a look at this link. Now, the second thing is that make sure that you name your function and parameters the same as what you see here, where it's called. And finally, try to use the same wording as the example output, namely, if it is a prime number, print it's a prime number in this exact wording. And if it's not a prime number, then print it's not a prime number with this exact wording. And finally, if you're still not quite sure how prime numbers work, then be sure to check out the Wikipedia page. And if your first language is not English, then be sure to switch to your native language just to know what it is, because I know it's called different things in different languages. Pause the video, have a good think about this, and see if you can solve this problem. All right, so let's think about how we might tackle this. The first thing I'm going to do is I'm going to create a new function called prime checker to be in line with this line, because I'm calling a function called prime checker, and then I'm passing in an argument to the parameter called number. So now that we've created our function, the next step is to figure out, well, what do we do in this function? Now, I mentioned that every prime number can only be cleanly divided by itself and 1. So that means that if it's divided by any other number other than these, it will have a remainder. So we know that we can use the modulus to check what the remainder is of a division. So we know that, for example, if we divide 6 by 2, then it equals 3 with no remainder, because 6 is divided into 2 3 times, while 7 divided by 2 equals 1, because there's a remainder of 1, because 2 times 3 is 6, and then 6 plus 1 makes 7. So we can use the modulus to check whether if the number that we're passing in here can be divided by all the numbers all the way down to 2. So, for example, if number was equal to 7, well, then what we would want to do is we would want to do 7 divided by 2, and then see if there is any remainder, and then 7 divided by 3, and see if there was any remainder, and then 7 divided by 4, and then we just go up 2, 3, 4, 5, and 6. And now we've basically divided 7 by all the possible values other than 1 and 7. So if any of these has 0 as the remainder, then it means that it does cleanly divide by one of these numbers, which means that it's actually not a prime number. But if all of these have a remainder, then that means 7 is a prime number, which we already know it is because we can see it on this graph. So how can we go through this process of getting this number divided by numbers starting from 2 all the way going up to the number -1? Well, we could simply just use a for loop, right? So we create a for loop and say for I, which is going to be this number that we're going to divide by, in, and that number is going to be a range of numbers. And the range starts from 2, because we're not going to divide it by 1. We already know that all numbers can be divided by 1. And we're going to put the range all the way up to the number -1. So now, inside this for loop, we can start doing our divisions. So we could take the number and we can use the modulo operator to divide it by I. So it's exactly the same as each of these lines of division. If number divided by I is equal to 0, so if it divides cleanly, well then in this case, it's clearly not a prime, right? Because if that number that we get passed in can be divided by any of the numbers between 2 and number -1 cleanly with no remainder, then that means it's not a prime number. However, if we get to the very end of our for loop and this if statement was never triggered, well then that means this is a prime number. So how can we represent this with our code? Well, we could create a variable called isPrime and set it to true. If this if statement gets triggered, then we switch this isPrime to false. And finally, once we get to the end of the for loop, we can go ahead and check, well, is prime true or is it false? And this expression is basically the same as just typing this, because this is going to be true or false. And if it's true, then we get to step into this block and we're going to print from this example output and say that it is a prime number. But else, or otherwise, then we're going to print the opposite, where we say it's not a prime number. There you have it. This is the simplest way of checking whether if a number is a prime number. And all it does is it checks through all of the numbers between 2 and the number -1. And if it's divisible by any of those numbers, well then it's not a prime. Now, out there in the real world, there's a lot of other ways that you could implement this function. And there's more efficient ways, there's faster ways, and there's lots of algorithms that mathematicians have come up with in the past. Now, for our case, what I'm really interested in is that you understand how inputs work and how you can use the argument that's passed in to the parameter inside your function in order to do something with it. As long as that's clear to you, then that means we can continue in the course and I can rely on the fact that this code or this code will not throw you off and you'll know exactly what's going on when it's being used inside the block of code and when it's being passed over into a block of code. In the next lesson, we're going to be putting all of our knowledge that we learned into practice and we're going to get started building our final project, the Caesar cipher. So for all of that and more, I'll see you there. All right, it's finally time to tackle our final project, the Caesar cipher. As I've mentioned before, Caesar cipher is this way of encoding text that was seen as early as during the times of Julius Caesar. So when he had these top secret military messages, what he would do is he would shift each letter of the alphabet by a certain predetermined amount. I want to show you quickly how this works. So we've got the alphabet here, and let's say we wanted to encode the letter E. So now we can line up the alphabet with a new set of alphabet, and at the moment the shift is 0 because the top alphabet and the bottom alphabet are lined up with a 0 difference. Now, let's say that we had a shift of 1. Well, then the alphabet moves to the left and A becomes B, B becomes C, etc. And we can keep going until we get to the amount of shift that we wanted. So let's say we're going to encode all of our text with the shift of 3. Well, then E becomes H, F becomes I, G becomes J, etc. And so on and so forth. And they've actually discovered these artifacts from ages ago where people have created these sort of dials. And by simply rotating the dial to a certain amount of shift, then you can line up the letters with each other. So A becomes N and Z becomes O and so on and so forth. And this is a way that people actually encoded top secret messages. By the end of this day, you will have also built a digital form of the Caesar cipher. And all you have to do is to type encode to start encoding a message. Let's say something like, hello world. And once we hit enter, we get to type the shift number, which I'm just going to choose a random one. and it gives us the encoded result. So now if I take this encoded result and I go ahead and type yes to restart my program, and I'm going to use the decode function to decode my message. Now, when I use the same shift number, then I should be able to get back the decoded result. So if there's people monitoring your phone, or you're trying to throw a message to your friend in a paper ball, then this is an easy way to ensure that if your message was intercepted, then it won't be understood by the other person. Once you're ready, let's get started by heading over to replit/@appbury/CaesarCipher1 start. And this contains the starting code for this project, and this is part 1 of 4. So here I've already saved you the laborious task of typing out all the letters in the alphabet, and they're stored in a single list. Now I've also got 3 inputs. So this is what the user is going to type in. They're going to type in encode or decode, and that's going to be saved to the direction. They're going to type their message, which is going to be changed to lowercase, and this is going to be saved in text. And finally, they're going to input a shift number, which is going to be converted to an integer and saved inside this variable called shift. So if you want to, have a run of the program as it is right now so that you fully understand what's actually going on before you get started. And remember, don't change any of the code above, but instead tackle the to-dos one by one. The first step is to create a function called encrypt that's going to take this text that the user typed in and the shift that they typed in as inputs. And this is going to use what you learned about functions with inputs from today's lessons. And then once you're done with that, step 2 is to go inside the encrypt function that you just created and shift each letter of the text forwards by the shift amount. So again, as we saw before, a shift of 1, a shift of 2, a shift of 3 basically just moves the characters forwards so that each letter of the alphabet becomes a letter of the alphabet much further down the line. And let's say that the user entered the text hello, and if we tried a shift of 5, then the end result should be MJQQT, and the printed output from this function should say something like the encoded text is this. And finally, you're going to call the encrypt function and then pass in the user inputs from over here, and you should be able to test the code and encrypt a message and see something like this happen. Pause the video now, have a look through the starting code, and once you're ready, go ahead and tackle it, and then come back and we'll go through the solution together. Good luck. All right, so I'm going to fork a copy of the starting file and tackle to-do number 1, which is to create a function, which is done using def, and it's called encrypt. And this function is going to take 2 inputs. So inside the parentheses, I'm going to put 2 parameters. Now, you can, of course, use the same word as the inputs that you're going to put into it, but in an ideal world, you try to not confuse yourself between the arguments and the parameters. So I'm going to call this plain text, this first parameter, and the second parameter, I'm going to call it shift amount. Now, of course, at a later date, when we're sending the input to this function, we're going to be sending the text to plain text and shift to shift amount. But keeping the names of the argument and the parameter different will help us later on to see which one is which. The next step is to go inside the encrypt function, which of course means indenting by 1. We're going to shift each letter of the text forwards in the alphabet by the shift amount and then print the encrypted text. This is going to be the challenging part of this whole exercise. But essentially, if we think about the problem, what we want to do is we want to take each letter in the plain text. So let's say our plain text is equal to hello. Then we're going to take each of these letters in turn and then shift it up in the alphabet by the shift amount. So let's say, for example, our shift amount was 5 and our plain text was hello. The first thing we're going to do is we're going to take the H, which is over here, and then we're going to shift it up by 5. So 1, 2, 3, 4, 5. And we're going to turn it into an M. We can start off by writing a for loop that loops through each of the letters in the plain text input. And then we can take each of these letters and work out its position in the alphabet list here. And we can do that by using the index method. So we can tap into a list, write .index, and then put in the value that we want to get the index for, and we should be able to get that as the result. So back over here, we're going to say alphabet is the list .index, and then inside the parentheses, we can put in our letter. So we want to find out the index of the letter that we're looping through in this alphabet up here. And once we've gotten a hold of that, we're going to save it into a variable called position. Now, once we've got that, then we're going to calculate the new position. Now, the new position is just going to be the previous position, which is going to be a number, and then plus the shift amount. So while we're going through this code, let's look at this word H. So the first time the loop runs, letter is going to be equal to H, position is going to be equal to 0, 1, 2, 3, 4, 5, 6, 7. And then the shift amount is 5, so 7 plus 5 is going to be 12. So now the new position is going to be 12, and we can tap into the alphabet list at position 12. So 7, 8, 9, 10, 11, 12, and get hold of the value at that position. So we can say that new letter is equal to the alphabet at the new position. And now, once we've got this new letter, we can create an empty string here, which we'll call the ciphertext, which is going to be the encoded text. And it starts out being an empty string. And then once we've gotten each of the new letters, we're going to add it to the ciphertext. Now, the final thing we have to do inside this encrypt function is once the for loop has run its course and we've added all of the new letters into the ciphertext, then at this point, it's a good idea to print out the output. And it tells us that we should say something like this, where we replace this final thing with the actual encoded text, which is of course called a ciphertext in our case. Now let's just make that into an F string so that it'll insert it when it runs, and we're ready to tackle the last to do. So here we're going to call the encrypt function, and we're going to pass in all of the user inputs. So remember that our parameter names are plain text and shift amount. So I'm actually going to use the keyword arguments. So I'm going to say plain text is equal to the text that the user has typed in. And then on the next argument, I'm going to say the shift amount is equal to the shift that the user has typed in. So now we're ready to test our code, and let's take a look at what happens. So I'm going to use this example that we've done here by trying to encode hello with a shift of 5. Now, the first thing that we type, the direction, doesn't actually matter because it's not being used anywhere in our code, at least not yet. So you can type anything you want. I'm just going to type in code, and then the message is going to be hello, and the shift number is going to be 5. And now it tells us that the encoded text is MJQQT, which matches with the expected output. You might think that we're done, right? This is perfect, this is great, and we've completed this entire exercise. But let's consider a different scenario. What happens if we tried to encode a word that had letters that were really close to the end of the alphabet? Let's say that we wanted to encode the message Zulu. Now, I'm only doing that because there's a Z in that word, of course, and we wanted to shift it by 5. Now, let's think what's going to happen, right? In our code, we're going to take each of the letters. We're going to take Z first, and then we're going to get its position in the alphabet and add the shift amount to the position to get the new position. Now, this is already at the end of the alphabet. So if this number, which is going to be 25, because there's 26 letters in the alphabet, and we start the position at 0. So this plus 5 is going to be 30. And what happens when we try to get the 30th item from the alphabet? Well, you'll find out when I hit enter. We get an index error, and it tells us that list index out of range, and it occurred on line 15. So just as we predicted, this does not exist. We have to try and tackle this, right? So if you haven't thought about this, this is the time to think about how can you solve this problem. I want you to pause for a moment and try to see if you can fix it. All right, so we know that this has a fixed length. And what we want to happen when we have a letter towards the end that we need to encode is to loop back to the beginning of the alphabet. So to solve this, all we have to do is just to copy the existing letters in the alphabet and then just duplicate it once more. So this means that if we find a letter that's Z and it needs to be shifted up by 5 letters, it's going to continue until it gets to E. Now, the really wonderful thing about this index function is it's going to give you the first index that it finds. So if we're looking for the letter A, it's going to give you the index 0, and then it's going to stop. It's not going to look for all the indices and find this one at position 26. So it means that our code will now work even if we have a word that have a lot of letters towards the end of the alphabet. Let's go ahead and give it a spin. Let's type in code, and our message is again Zulu, and we hit enter, and then we have a shift number of 5, and we get our encoded text. Z becomes 1, 2, 3, 4, 5, it becomes E, and U, 1, 2, 3, 4, 5, becomes Z. So now we've solved that small bug. Now, there's a lot of other ways that you could have solved this bug, but I think this is the easiest way without disturbing our logic here and not making our function even longer. If you had any problems with your code, then this is the time to go back and fix it. And make sure that you really understand everything that's going on here before you move on to the next lesson. But once you're ready, I'll see you on the next lesson where we're going to decrypt our code.